Hello, welcome to 12-3B, examples of the lens equation and ray diagrams. So let's start off with our lens equation. Our lens equation is 1 over dou plus 1 over di is equal to 1 over f. All right, 1 over dou plus 1 over di is equal to 1 over f. Dou, do, is the object's distance. Okay, so this is the actual distance of the object. Di, di, is the image distance. So do, object distance, di, distance of the image. Now one of the things to keep in mind is that your image distance, if it looks like it's in back of the lens, that means your sign is always going to be positive. If it looks like it is in front of the lens, that means your sign is going to be negative. And then finally we have f, which is our focus. So 1 over the object distance plus 1 over the image distance is equal to 1 over the focus. Now in physics we're used to working with meters, but we're not. This is all going to be in centimeters. All in centimeters. Please keep that in mind. It's all in centimeters. So you want them in centimeters. Okay, so let's label some of the things that we've been talking about. First of all, this is our lens. Our lens is fatter in the middle and thinner on the ends, so this is a convex lens or converging lens. Remember, it can also be called converging. Okay, these 2 points right here are your foci. Foci is plural for focus. Notice that you have one focus on each side of the lens. These 2 points will always be equal distances from the lens. Equal distance from the lens. Okay, the next thing we're going to be looking at is ray diagram. Okay, this is where we're going to draw lines to find out whether an image is upright or inverted and whether it looks like it's in front of the lens or behind the lens. So it's actually pretty simple if you just keep it simple. There's 2 lines that you're going to draw, and that is it. So to begin with, this green arrow right here that we have, right there, that is our object. The arrow is going to be our object, okay? Okay, so you take the top of your object and you draw a straight line to your lens. There's my straight line. And then I'm going to take that line from the center of the lens and I'm going to run it through the focal point. See how it's going through the middle of that focal point? So there's our first line. Our second line we're going to take from the top of the object through the focal point that's on this side of it to the lens, and then straight from the lens over, parallel. Where these 2 things meet is where your object's going to be placed. So if you look right here, our object, boom, is where your refraction ends up. That's where the image ends up. So if we look at this, we can tell our image is going to be inverted, which means upside down, inverted. It is going to be a real image, real, inverted, real. Real image, meaning that it looks like it's behind the lens, and then it is going to be reduced because this arrow right here is a little bit smaller than that one, so reduced. So our image is inverted, real, and reduced. Okay, so let's try this again. Let's see if we get an image with this. So our object is right there. We take the top of the object to our lens, and then we take it from the lens through your focus, right? Okay, so the next one we take from our object through our focus. Well, the other focus is over here. So are we going to have an image actually form on this one? No, we're not. So no image forms with this. No image. Okay, so in your modules, you have a lot more practice on ray diagrams and using the lens equation. I'm pretty sure you're probably going to need some help from your teachers, so make sure to take advantage of the one-on-one help that your teacher has available for you. Doing the ray diagrams especially, it's really simple, but it's still easy to get yourself confused. At this point in time, get a note card and write down on the note card any questions that you're somewhat confused about, and write it down. That way when you go talk to your teacher first of all can mark off that you did the note card, and secondly, you know what it is you want to talk to them about so you don't get all flustered, keep you on track. All right? You guys have a great day.
All right, ladies and gentlemen, now we're going to work with a ray diagram whenever the object is in front of our focal point. Now, the question being here, will there be an image formed? I'm going to give you guys a few seconds to go ahead and just think about that for a second. And if so, how would that image, how would we draw the lines for that image to form? We know that if it's right here, if our image, or not image, if our object is right here on our focal point, then there is going to be no image formed. However, if it's before that, something different happens. In fact, it's going to change the way that we do our ray diagrams altogether. So the first thing, we always want to go from the tip of our object to the center of our focal point. So we're going to go here to there. But from here, here's where it gets a little bit different. Here, we're going to take from here, and we're going to extend it through all the way across from our focal point all the way that direction. So that already in itself is a little bit different. The next thing that we want to do is for our next line, it's going to go from the center of our lens to the tip, through the tip of our object. So we're going to start here, and we're going to start here. And we're going to draw our line right there. And again, where this line intersects, where this line intersects is going to be where the tip of our image is going to be formed. So let's start here, and then go down from there. So the questions being, in relation to our object, is the image upright or inverted? Well, in this case, it's going to be upright, because inverted, it would be upside down. Is it going to be, as far as size, bigger or smaller, magnified or reduced? Well, compared to our object, it is definitely going to be magnified. All right, that's all we have for you today, and we'll see y'all next time.